Hello student, good morning. Today I want to start chain rule for differentiation. But before starting this chain rule, we can start only when you remember the formulas, standard formulas of differentiation which you have derived in class 11 from the definition of differentiability. Okay, these formulas now we have to remember. As a revision, I just tell you what are the formulas, and after that I'll go to the chain rule. And remember, if you properly remember your formulas, this is very important, then only you can use these results in chain rule, and chain rule you will get it easy. Otherwise it is very difficult. Okay, and when you understand chain rule, then only we can further proceed. And as you know, in class 12, maximum marks will be formed from calculus. Okay, so when you understand it properly at the beginning, then only it will be clear. Remaining things you will understand easily. So try to remember the formulas. I'll give you the formulas. Your first formula is ddx of x to the power n is equal to n into x to the power n minus 1. That means when we are going to use this formula, when the power is a constant. In the case of constant power, we are going to use this formula. And how to use? Power will come as a product and the power of the given variable will reduce by 1. That is n into x to the power n minus 1. Okay, try to remember it. Number 2, that is ddx of x equal to 1. Remember it? But actually it is derived from the first formula. X means what? Power is 1. Power is a constant. So if I use it here, it becomes 1 into x to the power 1 minus 1. X to the power 1 minus 1 means x to the power 0, which will give you 1 into x to the power 0 is 1. 1 into 1 value is 1. From here also we can derive, but if you remember this as a formula, it will be easy to do the calculation. That's why I am giving it as a separate formula. Now go to number 3. ddx of root x equal to 1 by 2 root x. You see, root x means also the power of x is half, which is a constant. So this is also derived from here. Let me tell you how. X to the power half root x means. So half will come as a product. Half into x to the power half minus 1. So half into x to the power minus half. X to the power minus half, if I write in the denominator, it becomes 1 by 2 into x to the power half. So x to the power half will be equal to root x. So the formula is 1 by 2 root x. Then ddx of 1 by x equal to minus 1 by x square. 1 by x means again the power can be written as a constant power, which is what? X to the power minus 1. From here also again you can derive. Minus 1 into x to the power minus 1 minus 1. So minus 1 into x to the power minus 2. That is what? Minus 1 divided by x square. So you see, the second, third and the fourth formula are derived, are corollaries to this first formula. So if you remember this formula, you can easily apply in question. Otherwise, if you forget, you can derive from here. But better to remember. Okay. So now I will go to the next formula. That is what? Number 5. ddx of c is equal to 0. That means where c is a constant. That means when you take the derivative of a constant term, it becomes 0. Constant means in this case independent of x. That is 0. Then the sixth formula is ddx of a fx. A is a constant. Fx is a function of x. So it is not constant because you are going to find out the derivative. When it is, this formula is applied, when it is given as a product of a constant with a function of x, then function a product will, constant, product of a constant with a function of x, the constant will come out of the derivative. So it can be written as a ddx of fx. Fx may be any function. It may be the previous functions. Okay. So when a function is given as a product with a constant number, the constant we can take out of the derivative. That is the application of this formula. Then the next formula, ddx of u plus v, where u and v are functions of x, not constant. So when it is given as a sum of two number, derivative of sum of two number can be written as what? du dx plus dv dx. Don't read it as du by dx, okay? Or ddx of u or by du dx. Similarly, either you read it as dv dx or ddx of v. Okay? So sum, you can write down the separately with both d dx. Similar case arise in the case of difference also. You remember, in all the cases I am considering here, u and v are functions of x. So the difference also, d dx of u minus v, can be written as du dx minus dv dx. What about the product? Product, you cannot write down it as du dx into dv dx. Product function, we can write down it as second function plus d dx of the second function into d dx of the first function plus first function into d dx of the second function. That means v d dx of u plus u d dx of v. This is the formula of product. Or you may interchanging the result. That means first you take the derivative of one function, taking the other as it is. Then you take the derivative of the other function, keeping other as it is. You may interchange their position also. That means you may write down it like this also. It will not matter, and the result will be same. Then what about the division? That is a quotient rule. d dx of u by v. The result is what? I am not saying in the derivation. Remember, we derived all this in class 11 from the definition, that is f dash x equal to limit h tends to 0, f of x plus h minus fx by h. Using that formulas, we have derived all this in class 11. So here we'll have it v square. Second function square, denominator square, always write down first, because otherwise you may forget it after doing all this calculation. So better first give this division sign, write down the denominator, then you write down the numerator. What is that? Second function, derivative of the first function, minus first function into derivative of the second function. It is similar we did, only this difference is the plus and the minus sign. So try to remember it. Okay, the next formula for trigonometric functions. d dx of sin x is cos x, d dx of cos x is minus sin x, minus, this is remember, d dx of tan x is sec square x, d dx of sec x is sec x into tan x, derivative of cot x is minus cosec square x, d dx of cosec x, that is derivative of cosec function, is minus cosec x cot x. Sin become cos, cos becomes sin, tan gives you sec square, sec gives you sec x tan x. The reciprocal are similar, you see, you can remember it. It is sec square, it is minus cosec square. And also you can remember one thing, when the trigonometric functions start with c, cos, cot, cos x, the results are negative. So try to remember this, try to practice it, read it, then it is easy for you to remember. Okay, now I'm going to the next formula, that is d dx of exponential function e to the power x is equal to e to the power x. Then d dx of logarithmic function log x is 1 by x. And one more formula, we have to derive this formula in class 12 also. After some time, or after the logarithmic function when we derive, differentiation when we do, we will derive this formula also, but try to remember now. That is d dx of a to the power x equal to a to the power x into log of a. Okay, here you see these are similar, power is variable, but here you can have any a, and this is only for e, exponential function e. Okay. Now, this product rule which we have got u into v, this can be extended further also, for 3 also. If I want to extend it for 3, this derivation also we will do at a time of logarithmic differentiation. So, first function you take the derivative keeping as it is the other two functions, that is vw d dx of u. Then take the derivative of the second function v, keep the others as it is. Then take the derivative of the third function, that is dw dx, and keeping the others uv as it is, where u is a function of x, v is a function of x, then w is a function of x. That is when it is the product of 3 function is there, we have to apply these things. So try to remember the formula. Again I tell you, then you can easily understand or easily apply your chain rule, because chain rule is simple. But when you do the application here, you have to use all the results which you have got earlier, or just I had given here. So what is your chain rule or differentiation of composite function? Without proof, I just give you the rule. You see, if y is a function of u and u is a function of z, that means y is related via u and u is related with x. Then if I want to take the relation between u and y and x, that is dy dx, d dx of y or dy dx. First you see as x is not a function of, here when you want to find out this derivative with respect to x, you cannot take the derivative of y with respect to x, because y is a function of u. So what we have to do? We have to take the derivative of y with respect to u, which we can write down it as dy du. But du is actually not present, so you have to cancel it. That means you have to do the product, du. And u is a function of x. That means we can take the derivative of u with respect to x. So first what to do? You have to change this x in terms of y, u, because y is a function of u. And after that, just to cancel it, you have to multiply it and again use a function of x, so I can take the derivative of u with respect to x. This is your chain rule. This rule can be extended further. That means for more than 2, also we can do this chain rule. So here I have taken y is a function of u, u is a function of v, v is a function of w, w is a function of x. Then if I want to find out the derivative of y with respect to this function, you have to relate with all this. Then only we can do the derivative. So how to get dy dx? Y, dy, we have to take derivative with respect to u. Then du, we have to take derivative with respect to v. dv, with respect to take the derivative with respect to w. Then dw, you have to take the derivative of w with respect to x. You see, just like these are cancelled out. du, dv, dv, and what is left? dy and dx. Got it? So you see, that means how to find out is ddu of y value fu can be differentiable by using the previous formulas. ddv of, you see, you can put the value of u here. What is u? zv. Then ddw of v value we can substitute hw, h of w. Then here ddx, what is w? P of x. So all this can be find out. So you see, as they are related like a bead or a chain, that's why this rule is known as a chain rule. Now how to apply? For the first question, I'll give you 2 methods of solving, but second one generally I prefer. That is the directly application of the formula. So your questions are of this type. Find the derivative of the following function with respect to x. Here y is equal to, first question I had given you, these are extra questions not from your book. Try to clear these things. In the next video, I'll do the problems of your exercise 5.2. Okay, so try to clear these things. So first question is y is equal to x square plus 3x plus 9. Oh, sorry, minus 9 to the power 9. Now you see the power is very large, 9. Okay, so it is difficult for us to do the expansion. You may expand it by using binomial theorem, but that will be very lengthy. So without doing the expansion, if you do the calculation, find out the derivative of y with respect to x, that means ddx. First, what to do? I have to give a name of this inside bracket portion to another variable so that it will convert to some standard formula. So your y is equal to what? X square plus 3x minus 9 whole to the power 9. I just name it as t, say. In that case, what happened? T is a function of x. Then your y become t to the power 9. Then y is a function of t. So I have to find out the derivative of y with respect to x, that is dy dx. But y we can take derivative with respect to t. That means we have to write down what? Dy dt. Then dt, t is a function of x. Is not it? T is a function of x. So ddx of t we can write. So what to do? ddt of, substitute the value of y, which is t to the power 9. Then ddx of what is t? T is x square plus this one. Now both of these are differentiable by using the standard formula. What is the formula we are going to apply here? You see, ddt of t to the power 9. You know the formula, ddx of x to the power n, we know. Power constant, that is our only formula. So if it is x, this is also x, then we can apply the formula. So here it is t, this is also t, so I can apply the same formula. So formula become, what is your ddx of x to the power n? N into x to the power n minus 1. So it become 9 into x, means here in this case t, 9 into t to the power 9 minus 1 is 8. Then here it you see, this is the derivative of sum or difference. That means ddx of u plus v and u minus v we can apply. Which will we give you? That is, when it is derivative is given as a sum and product or difference, then we can write down this using the results. What will have? ddx of x square, this is plus sign, so I'll put plus, ddx of 3x, this is minus, ddx of 9. Then after this, you can change, you have to ultimately, you cannot write down the result in terms of t. You have to change in terms of x all this. So 9, what is t? X square plus 3x minus 9 whole to the power 8. Let us take the derivative. This is ddx of x square. Again, I can use the formula of ddx of x to the power n. What is the result we'll get? N into x to the power n minus 1. That is 2 into x to the power 2 minus 1 is 1. Here 3 is a constant, so it will come out of the derivative by using the formula ddx of a fx. A will come out, that is 3 will come out, ddx of x. What is the formula of ddx of x? It's 1. And this is ddx of 9. 9 is a constant, so the derivative will be equal to 0. So here, as derivative is, when you use the formula, hope you remember, at that instant you have to remove this ddx symbol, right? So here all these ddx symbol are removed. That means you got your answer, and simplified form you write down. So this is 9 x square plus 3x minus 9 whole to the power 8, and this is what? Twice x plus 3. Now you see, I'm going to do, this is the method of substitution I have used. But sometimes what happens, one substitution is not sufficient. You have to use 2 or more than 2 substitution. Then in that case, the question is very lengthy. First you have to use substitution, then again change those substitution in terms your given variable. So it will be lengthy in this case. That's why I prefer to do it directly, thinking in your mind, using the previous formulas. Okay, I'll show you in this method. The same question I'm giving you by using that method, which you try to prefer. Generally, mostly I prefer this one. You have to get dy dx, that is the dx of, what is y? X square plus 3x minus 9 whole to the power 9. In this case, I'm not going to use any substitution. I'll think in my mind. That portion of the derived function, we have to think so that it is converted to some standard formula. So if I think x square plus 3x minus 9 as x, then your formula will become x to the power 9. You think it as x. I'm just marking here. I'm thinking this portion as x. Think it as x so that it is converted. You have to remember the formula. Then only we'll understood which portion we have to think so that it is converted to certain standard formula. So I have think here this portion as, just a minute, okay, as x. It become x to the power 9. What is the formula of x to the power 9? And 9 into x to the power 9 minus 1. That means 9 into x to the power this. But x, you think it, don't write it as x. So 9 into this portion to the power 9 minus 1. And take the derivative of that portion which you have think it as x. তোমালোকে তাৰমানে এইখিনি ভাবি লোৱা ভাবি তোমালোকে এটো x ভাবা ভাবি পাৱাৰ টু কনস্ট্যান্ট ললা এটা x to the power 9 ফৰ্মুলা হৈ গল x to the power 9 হলে কি হয় 9 into x to the power 9 minus 1 আৰু যিখিনি পোৰশনক তুমি x বুলি ভাবিছিলা সেই পোৰশনটোৰ যেতিয়ালৈকে ডাইৰেক্ট ফৰ্মুলা এপ্লাই নহয় তেতিয়ালৈকে তুমি ডেৰিভেটিভ লৈ যোৱা so here I have to take derivative of this portion which I think it as x square plus 3x minus 9 right. So this calculation is, it is independent of ddx, so it is done. 9x square plus 3x minus 9 whole to the power 8. Now I have to write down the dx of this portion plus the dx of this one minus the dx of 9. As I have done in this case, this is the step. I skip here. If you want, you can write down. And then I take the derivative. I have done here the derivative directly. The dx of x square, which is 2 into x to the power 2 minus 1. 3 is constant because this type of question we have done in class 11. So many questions we have done. So 3 is constant, it will come out, the dx of x is 1 and the dx of 9 is 0. So doing the calculation, what we have got? 9 into this portion, this is keep it as it is, twice x plus 3. You see, you have got the same answer, but this is shorter than the previous one. Okay? Now, I will give you a few more examples. ddx of root over x square plus twice x minus 3. So, just by seeing the question, you understand that to which form I can convert it. You have only one formula for root x. Root over term is there, and then only we have one formula, that is the formula of root x. Is not it? So, I'll think this portion as x. Then it will convert to ddx of root x formula. What is the derivative of root x? Is 1 by 2 root x. So, 1 by 2 root x. This is, you think it as x, but write down whatever you think. Tumi jitu bhabisa hetu he bohuaba. Bhabi thaka x buli likhute kintu etu likhiba. And that portion we have, which you have considered as x, take the derivative of that portion. The dx of this I have think as x, so I am taking this derivative. Keep it as it is, take the derivative of each and every function separately. The dx of x square plus the dx of twice x minus the dx of 3. The dx of x square is what? That step I skip. The dx of x square is twice x. 2 is constant, the dx of x is 1 and the dx of constant is 0. So this is done. And do the simplification, 1 by 2, this is keep it as it is. Here we can take common 2, 2 and 2 are cancelled out. What is left? X plus 1 divided by root over x square plus twice x minus 3. So here the solution is completed. Now proceed to the next question. ddx of sine of x square plus 5. So here what is the portion you have to think as x so that it is converted to standard formula. Sine is there. There is no power. So you know one formula for sine x. If I think it as x, this portion as x, it will convert to sine x formula. What is the sine x formula? That is derivative of sine x is cos x. So cos of this portion. That portion which you have think it as x, take the derivative of that portion. That is what? ddx of, this is x, so x square plus 5. Keep it as it is. What is ddx of x square plus 5? ddx of x square plus ddx of 5. ddx of x square is twice x, ddx of 5 is 0, so I have not written here. So twice x you can write down before and then you write down cos of x square plus 5, which is completed. Now go to the next question. ddx of sine square twice x minus 3. You see, if I think this portion as x, it will convert to sine square x formula. Is there any formula for sine square x? No, no standard formula for sine square x. That's why what to do? I have to write down this power is a constant, you know. This can be written as sine square theta can be written as sine theta whole square. So I can write down this as sine of 2x minus theta whole square. Now if I think this portion as x, this become power constant. So x to the power n formula. What is x to the power n formula? Nx to the power n minus 1. So 2 into this function to the power x minus 2 minus 1. Think this portion as x. That's why I take this portion of derivative. This is completed. After this is done. But again I have to take derivative of this function. In this case, if you see as earlier, if you think it as x, it becomes sin x formula. So I can think it as x because there is no power now. So what is the derivative of sin x? Is cos x. So cos of this portion. But again I have to think this portion as x. So take the derivative of that portion which you have to think. So you see, this is one step more than the previous questions, is not it? Here I have to think twice. Then taking the derivative 2 sine of this, 2 of this one, ddx of 2 constant, ddx of x is 1, ddx of 3 is 0. This is done. But now you see, you can stop here into 2 into this way, we can write down the answer. But you see, if this, since this is in the form 2 sine theta cos theta form, so I can write down it as sine of 2 theta formula. So I have used it, but without using, if I stop here, then also you will get full marks for that. So sine of 2x into 2. But these things you have to know because later on you have to do second derivative also. But for second derivative, you have to simplify. Then only we can proceed to second derivative. Okay. So here I have done the simplification. 2 times of this portion, twice a formula, 2 into this is into 2 is there. 2 come outside and sine of 2 to the 4 minus 3 to the 6. So this is the answer. Now go to the next question. ddx of cos of x cube. Here you see, ddx of cos of x cube means the function of x as angle of x is cos theta is x square. So here we can think it as x. Then I can use the formula of cos x. Is not it? So cos x is minus sin x. So minus sine of x cube. You have think it as x. So take derivative of x cube. This is minus sine of x cube. I can use the formula. This is 3 of x square. You see the difference between these two equations. ddx of cos cube x. Cos cube x means cos x into cos x into cos x. So here we can write down it as a power. You cannot think it as x now, as there is power. So cos of x whole cube. You see the difference? Have you noticed the difference between these two equations? So this now we have to think it as x. It becomes x to the power n. 3x to the power n minus 1 into ddx of cos x. What is the derivative of cos x? 3 into this can be written as cos square x. Derivative of cos x is minus sin x. So the answer is minus, I am writing outside, 3 into sin x into cos square x. So this is the solution. Okay, few more questions I had done here. So you see the next question, ddx of sine of root over sin x plus cos x. So what is your x now? No power is there. So sine of x, you can think it as x. If I think it as x, take the derivative of this portion x. We have to do separately. Then cos sine of x. Sine of x formula is cos of x. Cos of this portion, ddx of this portion. Now what to do? This is root x form. Is not it? So you have to think now sin x plus cos x as x. Keep it as it is. ddx of root x formula, 1 by 2 root x. You do ddx of this portion which you are thinking is x. This one. Then here keep it as it is. This is derivative ddx of sin x cos x. ddx of cos x is minus sin x. So here the solution is completed. I have written one more step, or you can stop it here also. Here also stopping also you will have full marks. So cos of root over sin x plus cos x into cos x minus sin x whole thing divided by this portion. Now let us proceed to the next question, number 9. ddx of sin 3x into sin cube x. This is the product of two functions. So you have to use product rule, u into v. What is your formula? U ddx of v plus v ddx of u, or v ddx of u minus u dd plus u ddx of v. That is derivative of the first function, keeping the second as it is. Derivative of the second function, keeping the first as it is. So here I have written one function. Ebar tomalke eta function derivative loa, itu rakhi dia as it is, or ebar hitu loa, itu as it is rakhi dia. So first function I have to keep it as it is, ddx of the second function plus second function into derivative of the first function. Okay. So here sine 3x, it is the power, so I have to think it is like this. Sine cube x, but here it is not the power. This angle you have to think it as x. So cos of thrice x is the dx of thrice x. Sine thrice x, power is there. So x to the power n formula, n x to the power n minus 1, ddx of, again you have to think it as x. So ddx of sine x. Sine cube x, cos thrice x, now this is done already. 3 is constant, come out, ddx of x is there. So it becomes 3 constant, sine 3x into sine square x, ddx of sine x is cos x. Here no thinking is there, that's why it is completed. 3 is again here, first I am writing sine cube x, cos thrice x into ddx of x is 1. So here the solution is completed. Next question, ddx of twice x by 2 tan x by tan x plus cos x whole square. So again the power is constant, power function is there. Power thoka amar etai formula. That is, what is the formula? X to the power n. So n x to the power n minus 1 into ddx of this portion. This is keep it as it is, 2 to the 4x, sin x plus sin x, it is what? U by v rule, functions of x, functions of x. So v square, v ddx of u minus u ddx of v, that is v square is this much. This function into derivative of this minus this function into derivative of this portion. So doing the calculation, keep it as it is, tan x plus cos x, 2 is coming out, ddx of tan x is x square x, minus 2 tan x, take the derivative of u plus v rule, ddx of tan x x square x, plus ddx of cos x is minus sin x, so I have written directly minus sin x, and this is your solution. So today I stop here. So you just listen to the video properly. First you listen it carefully, then write down your solution. Okay, thank you.